Picture a place on the map where almost nobody lives, where clouds are a rarity, and the sun shines almost non-stop for 300 days a year. The Sahara, the largest hot desert on the planet, millions of square kilometers of sand and rock that, it seems, are completely useless to anyone. For years, humanity has been fighting over oil and gas, countries argue over pipelines and deposits, and right here lies this unclaimed land, where the sun shines almost without a day off, and the technology to turn that light into electricity has been around for a long time. Solar panels are nothing new to anyone, and they get cheaper every year. What if we just covered this piece of useless desert with them? What could be simpler? If you estimate how much energy could actually be generated from such an area, the number you get is just astronomical. If you were to cover a little over 1% of the Sahara with solar panels, it would be enough to provide electricity for the entire planet. All the factories, all the cities, all the homes, all the phone chargers, literally all of humanity at once. And you would still have 99% of the desert left over. It would seem that here it is, the solution that was lying on the surface all these years. Simple math, cheap land, endless sun. In reality, talks about this have been going on for more than 15 years. They drew up plans, ran the numbers, discussed it at the highest levels. But not a single power plant of this scale has appeared in the desert, not one. Why? The first thought, of course, is money or politics. And yes, it's true. Projects like this cost billions of dollars and require agreements at the level of leaders from many countries. But there's a second question, one that's far more alarming. What if the real reason isn't about money or politics at all? What if the scientists who seriously took on the task of calculating this idea stumbled upon something that could call into question the very existence of all life on the planet? It's almost impossible to grasp the size of the Sahara from a map. 9 million square kilometers sounds like a dry statistic, until you realize that this desert is larger than the United States or China. It stretches across a dozen countries, from the Atlantic Ocean almost to the Red Sea. And if you fly over it for several hours straight, almost nothing will change under the plane's wing. Just the same sand dunes for thousands of kilometers. Cover all that land with solar panels? A project like that would stretch on for decades. But in reality, to provide electricity for all of humanity, you wouldn't need to cover that entire endless desert with panels. According to various calculations, an area roughly the size of a not-so-large European country would be enough. On a map of the entire Sahara, such a plot would look like just a small spot somewhere in one of the corners. Imagine, a small piece of the desert, covered in solar panels, could replace oil, gas, and coal for our entire civilization. And unlike all of Earth's resources, the sun's energy is renewable. Every day, billions of kilowatts of clean, renewable energy are simply going to waste. The figure of 1% of the Sahara's area didn't come from some viral post online, but from an ordinary thesis paper. Back in the mid-2000s, a German researcher calculated how many square kilometers of North Africa would be suitable for this type of power station. It was pure engineering math, plain and simple. But the calculation didn't just sit gathering dust in a university archive. It was picked up by major energy companies, and then by the governments of several countries, and the topic quickly escalated to the level of international negotiations. Similar calculations weren't just made for Africa. For one region of the United States, the picture looked almost the same. An area the size of a single state could theoretically cover the entire country's energy needs. It's just that in the Sahara, this math looks the most impressive. An endless desert, where the land seems to be useless to anyone, sounds way more convincing than one state in the middle of a densely populated country. From the outside, the whole idea already looked like a ready-made solution. All that was left was to just go and build it. The first serious attempt was made pretty quickly. The calculations were taken off the page and turned into a real project, right away on a continental scale. In 2009, a serious attempt was made to bring the idea to life. A consortium of European banks and industrial giants launched a project with the telling name Desert Tech. It promised to cover up to 15% of Europe's electricity demand. The stations were supposed to be set up in the deserts of North Africa and the Middle East, and the target date was set for 2050. The project's budget was estimated in the hundreds of billions of euros. On paper, everything looked flawless. But just a few years later, the biggest participants started pulling out one after another. The project itself basically fell apart, having never built a single station on the intended scale. The problem turned out to be not with physics or the sun. It was a mix of the region's political instability, a border between two key countries closed due to a territorial dispute, and the outrageous cost of transmission lines over such a distance. The idea didn't die because of bad calculations. It died because of people and borders. By that point, engineers had almost figured out how to solve one problem, and that is where the story takes a much more unexpected turn. One of the technologies they plan to install in the desert works using mirrors that heat a fluid. To cool a station like that and to regularly wash the dust off the panels, you need a significant amount of water for every kilowatt hour generated. In a region where water is more precious than any other resource, this created an unexpected conflict of interest. The station was supposed to bring clean energy, but it would take water from the local residents, for whom every single drop counts. The desert generously provides sun, but it doesn't provide water. It was this detail, and not just politics and money, that almost killed the project on paper, long before the first foot of transmission line was ever built. Let's say the money, borders, and water issues somehow get resolved tomorrow. A question that no one took seriously for a long time would still remain. What happens to the land itself when it's covered with dark panels instead of light-colored sand? Sand reflects most of the sunlight back into the sky. The dark surface of the panel, on the other hand, greedily absorbs this light. Some of it goes into electricity, but a portion inevitably turns into heat right at the Earth's surface. This heat warms the air above the station more intensely than over the regular desert nearby. The warm air rises and starts a movement that was almost non-existent in this place before. This is the exact change, a seemingly simple one, that climatologists started plugging into their models. They wanted to figure out what it would lead to if it was replicated not just at one station, but on the scale of the entire Sahara. Imagine for a second a giant invisible furnace, hundreds of thousands of square kilometers in size, just sitting right in the middle of the desert. That, in a nutshell, is how a huge field of solar panels behaves. The rising warm air above the station strengthens the upward currents in the atmosphere. And this, in turn, helps clouds and rain form where before, not a single drop might have fallen for years. According to climate model calculations, if about 20% of the Sahara's area were covered with panels, the local temperature above the station could rise by about 1.5 degrees. And rainfall in the arid belt south of the desert could more than double. So you get something unexpected. A station built for clean energy also turns into a rain-making machine in one of the driest places on the planet. And that is just the beginning of what scientists found in these calculations. The question isn't about the panels, it's about the desert itself. Was the Sahara always as dry and lifeless as it is today? The answer completely changes the picture you have in your head. Just 6,000 to 11,000 years ago, which is practically yesterday in geological terms, a savanna with lakes the size of the Caspian Sea stretched across the land where the dunes are now. You could find hippos, giraffes, and crocodiles there. The people of that time left behind thousands of rock drawings of hunts and pastures, which are still visible on the desert stones. The reason for that green era was a slight shift in the Earth's axial tilt, which intensified the monsoon rains. The vegetation handled the same task that the dark panels are solving today. It absorbed light instead of reflecting it. And by doing so, it ramped up the rains that it sustained in the first place. Nature has already shown in practice that turning the Sahara from a desert into a green land isn't some fantasy. It's a real physical scenario that already happened once, without any human involvement. What happened to the Sahara 6,000 years ago was a natural process, one that stretched out over thousands of years. Modern models are looking at a completely different scenario. The very same mechanism, but triggered not by nature, but by engineers. And not over millennia, but in just a few short decades. If you kickstart that same mechanism artificially, with panels on an industrial scale. The rain in Africa will turn out to be just the beginning of the story. Next, the entire planet's atmosphere comes into play, and a whole lot more than the fate of a single continent will be on the line. The planet has a narrow band closer to the equator, where more than 30% of all the Earth's rain is born. It's this very band that feeds moisture to the forests of the Amazon and the Congo Basin. The models show once you heat up the Sahara with a massive build-out of panels, this rain band starts to shift north toward the new heat zone. The rain obediently follows wherever it's warmer. In those same calculations, the Amazon loses about as much rainfall as the Sahara gains. According to various estimates, that's anywhere from 10 to 30% of the region's usual amount of rain. For the planet's largest tropical rainforest, a loss like this is already being felt. It means the risk of significant droughts in places where water was always more than abundant. An attempt to solve a problem in one place can create another one tens of thousands of kilometers away. The heat generated over the Sahara doesn't just stay there. The atmosphere and the ocean carry it all across the planet, reshaping the usual air and water currents far beyond the African continent. In these models, it's not the tropics that warm up the most, but the polar latitudes. Because of this, the Arctic ice begins to melt faster than usual, losing area year after year. The altered wind circulation, according to calculations, could increase the likelihood of tropical cyclones off the coasts of North America and East Asia. Storms in places where they were once considered a rarity. Even a very small shift in the planet's average temperature, just tenths of a degree, is capable of setting off a chain of consequences in these scenarios. It would have been impossible to predict it in advance just by looking at a map of the desert. But there is another side to the very same calculations that scare us with the Amazon and melting ice. They simultaneously show a benefit for Africa itself, and it is worth seeing this before getting scared any further. Additional rain means additional vegetation in the arid belt south of the Sahara. And vegetation, as we have already seen with both the panels and the ancient Sahara, only accelerates that same rainfall even more. The good news is that once such a cycle gets going, it starts to feed itself. Nature no longer needs to reinvest every year for the effect to keep working. In some calculations, the effect from just the wind and solar farms in this belt explains up to 80% of the total increase in precipitation, precisely because of this chain reaction. The same climate change can make one continent greener and simultaneously dry out another. And this is not a flaw in the model, but its main point. Scientists openly admit that the calculations are still missing one important component: dust. The very same dust that the wind regularly kicks up from the surface of the Sahara and carries across the entire Atlantic Ocean. This dust serves as a source of minerals for two distant ecosystems at once. For the very same Amazon rainforests and for the oceanic plankton off the coast of Africa, which desperately need these minerals. If the panel station noticeably greens the desert, the amount of dust kicked up will inevitably decrease. And then the effect on the Amazon in reality could turn out to be even stronger than what the calculations have already shown. The authors of these studies are themselves being completely honest. We are only just beginning to understand what would actually happen if you were to build something like this in real life, and not in a model on a computer screen. It turns out humanity already has unintentional experience setting off the exact same mechanism, just in reverse. Way back in 1975, a climatologist proposed something that was later confirmed in practice. Overgrazing by livestock in the arid belt south of the Sahara is destroying the vegetation. The exposed, light-colored soil begins to reflect more sun than before, when it was covered by grass. The air over soil like this cools and sinks down instead of rising up, and that means rain stops forming, which kills even more of the vegetation around. This is how herders, without even meaning to, made the droughts in this region worse for decades with their herds. The mechanism that could make the Sahara green with panels turns out to be the very same mechanism people use to accidentally turn the savanna into a desert, just flipped in the opposite direction. Let's go back to that image from the beginning. That tiny percentage of the area, that imaginary little square on the map, the promise to cover all of humanity's energy needs with a single stroke of engineering genius. But now we have answers to both questions asked at the start. The project wasn't built not because the idea was bad, but because borders, money, and water turned out to be more complicated than any formula on paper. And if it does get built someday, it won't just be about clean energy. The planet is much more connected than it looks on a globe, and the rain taken from one continent might just fall on a completely different one. A dried-out rainforest, melting ice, more frequent storms. Each of these consequences taken separately looks like a problem for just one region. But together, they add up to exactly what the very first question of this story warned about: a risk to the stability of the system on which life across the entire planet depends, not just in one part of it. The Sahara seems like the most empty and silent place on Earth. But if the climatologists' calculations are correct, that is precisely where one of the switches connected to the entire planetary climate system is located. And humanity has not even decided yet whether it is worth touching it at all.